Okay, a sphere is a set of points in space that are all equidistant from the center. So a circle had a very similar definition when we did it, but a circle is just a two-dimensional circle. This would be a set of points in space, so it makes that three-dimensional ball, if you will. A lot of the same words apply for a sphere as it did for a circle. A chord would just be connecting 2 points on the sphere. The radius would go from the center to any point. When we're talking about the diameter of a sphere, we're talking about it going through the center. And we could have tangents or secants or all of that stuff like we did for circles, except now we're talking about it being three-dimensional. So today we're going to look at surface area and volume of spheres, also hemispheres, or half of a sphere. Okay, so the surface area of a sphere is 4 times pi r squared. And this picture doesn't show it very well, and I don't know how well this copied on your paper, but have you guys ever seen like a tennis ball, how the stitching of a tennis ball is kind of like put together? You kind of have 2 oblong like pieces of fabric. Can you envision there kind of being like 4 circles within that? The overestimate area of each end, this is probably a better illustration of that, gives you the approximate, but you'd have, 2 of those stitched together for that tennis. The surface area of a hemisphere would not just be half of 4 pi r squared. So this is the best illustration that I can show you to show you why this would not just be half of the surface area of the sphere. If you thought of like this being the sphere, the hemisphere actually has like kind of a closed system to it. So it'd be like this portion, and then you'd have to add on that circle to get the whole surface area of the whole hemisphere. So you'd be adding on pi r squared. So you could write like this right here is half the sphere plus the circle. Okay? I don't like the way this looks. It looks way more complicated than it has to. Lydia, you know how we can simplify it? It would be 3 pi r squared. Half of 4 pi r squared would be 2 pi r squared, plus another pi r squared is 3 pi r squared. So this is how I'd remember it, but this right here is why it is what it is. Okay, some other vocab for you. The great circle is the biggest circle. It is the circle that contains the center.
And it's great.
And it's great. So if this were a hemisphere, this circle here would be the great circle. Okay. And I guess we probably should have defined this first, but the hemisphere is half the sphere. Just like on the globe, you have like the northern hemisphere and the southern hemisphere. It's half of the sphere. Okay, one other piece of information you need to know, these 2 points are called poles when they're on the great circle, and they'd be like, they go through the diameter. They're like directly opposite from each other, just like the north and south pole are directly opposite from each other on the earth. Okay, so when we're using this, we want to find the surface area of each of these figures and round to the nearest tenth. So this first one, it gives me that we want to find the surface area of a sphere. Surface area of a sphere is 4 pi times the radius squared. However, they don't just say here is the radius. They tell us that the circumference of the great circle is 16.2 pi. So if this is the circumference, can we find the radius. Yeah, and we did this for the warm-up today. Circumference is 2 pi times the radius. So if the circumference is 16.2, when I'm solving for the radius, I'm sorry, pi, and dividing by 2 pi, well, those pi's are going to cancel. 16.2 divided by 2 is 8.1. So the radius is 8.1, and then you can take that. Remember, your final answer is what is the surface area of the sphere. So I can plug that in, 4 pi times 8.1 squared. So this answer here is going to be about 824.5, and that'll be square feet because we're talking about surface area. Yeah.
Because the circumference is written in the exact form, would you write the surface area in the exact form or not?
You could, if you wanted to, if you'd rather for that. I think maybe just because the direction said round to the nearest tenth, so if you're not going to write it in the exact form, just write it that way. I can go both ways, and I don't really care, especially if you want to like leave it in exact form. I kind of prefer that too.
Okay.
I just know most people kind of prefer it as a decimal. Wait, the next one, it gives us the hemisphere, and it gives us the area of the great circle. So if this is the area of the great circle, you have some choices. Okay, this would be my guess as to how most people would do this. Area equals pi times the radius squared. So the area 94 equals pi times the radius squared. Go ahead and divide by pi, and then you take the square root. So the radius is about 5.4700. We want to find the surface area of the hemisphere. So the hemisphere is going to be 3 pi r squared. So then you could do 3 times pi times 5.47 squared. And I still have that on my calculator, so I think I just start with that, square it, and then multiply by 3 pi. The answer is 282 square millimeters. Any other ideas as to maybe how you could do that one? In a way that would be way simpler than what we just did. This number here is what pi r squared is, correct? Any ideas as to what you could do?
Could you multiply by 3, but then you'd have to divide by 2 since it's half, wouldn't it? No?
This is the formula for a hemisphere. It's 3 times the area of the circle. So you don't have to divide it by anything. You could just take that 94, multiply that by 3, and you get 282. Okay? I wanted to go through the process just in case you don't recognize that. Sometimes you might still have to go through the process to do something, but there might be some shortcuts for some of these. Not if you leave all those digits on your calculator. I got exactly 282 because I left all of this on my calculator and then just pushed squared times pi times 3. And then you'll get exactly 282. Okay, the next one, they give you the circumference of the great circle. You can't do the same thing here because they're not giving you the area, they're giving you circumference. So circumference is this, I want to find the radius. So the circumference is 36 pi. I'm trying to find the hemisphere, which is 3 pi times the radius squared. So I'm dividing them each by 2 pi. So the radius is 18 centimeters. I can then take that and plug that in for the radius. So 3 pi times 18 squared. Lydia, if you'd like to leave it as 972 pi, you can. For those of you that prefer the decimal, it's 3053.6. Both of those would be square centimeters. Questions so far? Little circle review as we get into surface area. Okay, when we're doing volume, the only thing you need for volume of a sphere is what the radius is also. I wanted to kind of develop this very briefly. You can kind of think about taking a sphere and making a whole bunch of pyramids out of it. Formula for a pyramid is 1/3 the area of the base times the height, which would be the radius of the sphere. So the formula is directly related to this, except the area of the base is the part of the circle, the surface area of the circle. If you take all of those and add them together, all of those bases are going to add up to be the surface area, which is 4 pi r squared. Correct? So the volume is 1/3 times 4 pi r squared times the radius, which is the height of that pyramid. If I go through and simplify this a little bit, 1/3 of 4 is 4/3. And the radius squared times the radius is the radius cubed. This would be the way the formula looks on your formula sheet, but this is where that comes from. So really, like, all of these formulas tie back to like the prism. Okay, so finishing this up, we want to find the volume of the sphere or the hemisphere. The hemisphere for volume is just really just half of whatever the other one is. You don't have to do anything fancy with like that extra circle that would be there. So the sphere with the great circle, the circumference, this is the circumference, so that makes the radius. Can I just jump to this and say the radius is 15? Are we good with that? Dividing by 2 pi? If I just make that step. So the radius is 15. Oh, you know what, I guess it even gave it to you right there. I guess they didn't have to have that picture drawn for you. What is the volume of this sphere? Well, you could take 4/3 pi times the radius cubed. Sometimes students think that they have the wrong answer because they get such big numbers for these. It's because we're cubing a number. So it will be something pretty big. Type this into your calculator just to make sure you know how to type it in. It is 4,500 pi, or if you have it as a decimal, 14,137.2. Both of these would be centimeters cubed, depending on, you know, however you wanted to read it. Okay, for this next one, it gives us the diameter, so make sure you have the radius in the formula. The radius is 3, and because this is a hemisphere, you need to make sure that you just find half of the volume when you're done. So if you want to put that into the formula, you can. Otherwise, you can just find the whole volume and then divide by 2 in the end. But just make sure you do that last step. So I'm going to do 4/3 pi times the radius cubed So the whole thing would be 36 pi or 113, and then you can divide it by 2. So you get either 18 pi or 56.5, and this is going to be cubic feet. Questions on those? Okay, just make sure you're typing into your calculator and you're getting the same thing I am. Okay, this last one, I was thinking of all you soccer girls, put this one in there. So the soccer ball globe at the right was constructed in 2006 for the World Cup soccer tournament. It takes 47,916 pi, so that's not even the answer, like the answer would be multiply that by pi, cubic feet of space. Assume the sphere is or the globe is a sphere, what is the circumference? So they want us to find circumference. I need to first find the radius, and then I can find what the circumference is. So this is the volume. I'm going to set that equal to 4/3 pi times the radius cubed. And then I'm going to divide by 4/3 pi. The pi's cancel out. If you don't want to divide by that fraction, you could always multiply by the reciprocal. So if you do 47,916 times 3/4, or just divide by 4/3, doesn't matter, you get 35,937 equals the radius cubed. How can I find what that radius is? What would I do?
That's in that spur, just what you think I've always seen next to the spur.
Okay, and what's that called?
That's a very good question.
And you remember what that's called?
Cube root.
The cube root. Does everybody know how to type that into your calculator?
No.
Okay, if you have a calculator like mine, you push 3, and then you push the one above the square root button. It's like the second caret button, and it'll look like this. Okay, that's how it'll look on the calculator if you have one of mine. If you have a graphing calculator, if you go to math, and like part of the menu, you can do cube root. Okay, and then you type in the 35,000 number. So try this on your calculator. The radius is 33. That's not the final answer though, because the question's asking for circumference. So circumference equals 2 times pi times the radius. So then you would multiply that out. The final answer for circumference would be 207.3, and that is feet.